Well, hello friends. Welcome back to the program. Today we are going to do a little refactoring in our JavaScript engine. So I've been working on this big project to garbage collect the entire web DOM over in the web engine. But today I was talking to Linus about something that always bothered me in our JavaScript engine, and I'll show you exactly what it is. So let's look at JavaScript array, for example. So here is the problem right here. We have a public constructor, and we don't want you to actually ever use this constructor manually. We want you to use these helpers, create, because they actually go and talk to the garbage collector and allocate something from that heap, construct the object into a proper allocation from there. But we are forced to make these constructors public because of the way that the heap allocation is implemented. So what we do to actually allocate and construct the object is that we call on the heap allocate, passing in as a template parameter the type that we want to allocate. And then allocate in turn goes and allocates something of the appropriate size from the GC heap, and then invokes the constructor using placement new here, as you can see. So this placement new right here is the whole reason that everything in the everything GC allocated in libjs, libweb, and other things that also use libjs, they all have public constructors, even though we don't want you to use them. And it's been like that since forever, and it just kind of sucks. But today I just randomly had an idea that why don't we try to get rid of that so that the constructors don't have to be public. And I talked to Linus about it and he got excited. So I thought, I'm just going to make a video showing this thing because I think it's going to be very, very satisfying to actually go and make all these things private or protected so that you can no longer call them. So let me show you the basic idea. So in order for heap to be able to allocate these, we have to that's why we make them public. But what if we could make it a friend? So if we could make this function here be a friend of every class, and you could do that by just having a little bit of a thing, right? Where you take this and then you would put it at the top here. I guess something like that. And I think this should work, right? But it is a bit of a mess, and it's definitely a mouthful. But let's at least check that it still builds if you do that. It did not build. Let's see. Oh yeah, of course, because I have to say heap allocate. All right, so far so good, but obviously we don't want to be putting this at the top of every, or in every class that we ever declare, because it's just such a repetitive thing. But what if we were to just put that into the JS object macro, which we already put into every object subclass? So this would just go in here at the bottom, right? So something like that. And actually my OBS doesn't like it when I build quite that aggressively. Let's see. Okay, so now we're getting a bunch of errors because we have invalid use of incomplete type JS heap. So we have a bunch of cases where heap is not included. So it's not quite this simple, right? And I think we can't just include heap from here, or maybe we can, but what if we didn't have to? What if we could just do, what if we could just make a helper here so that we don't have to know about the heap class, but instead this could just be a helper like construct cell, a global helper in the JS namespace, and then we will put that outside here. Construct cell, let's say, and it will be something like this. So we will pass in a memory slot that we've already allocated, and then we're just going to placement new into the slot with T, and then we're going to forward the all the arguments that we have, if any. Okay, and then we can make these actually use, oh wait, hold on, let's make it return slot as well. Okay, so now we can use it here. Return construct cell into memory. Like that, okay, and here cell is construct cell into memory. I guess that works. This thing also calls initialize on memory, which is a cell, but we have a stronger type. So I guess we can just use the stronger type. That should be fine. Okay, so now this is a free function, and I think we should be able to use a free function here without having to know about heap. All right, so now what's the problem? Unused parameter args. Oh, shoot. How did I mess that up? Where was that? 51. Oh yeah, right. I have to pass them along, of course, so that we don't lose the constructor arguments. Okay, and now we have declaration of template parameter T shadows template parameter in array iterator prototype. So array iterator prototype, where is that? It shadows a template parameter. Oh, right. So typed array already has a T, so we can't be putting something called T in here as well. So let's just come up with a non-overloaded name, like construct cell type or whatever. It just has to be something unique to that particular declaration. All right, so now what's wrong? Protected. Okay, so JS array is protected. The constructor is protected in this context. Oh, wait, do I have to? Just thinking, does this thing have to be called construct cell type? I don't think it needs to, but maybe I'm not right about that. Okay, so what thing am I looking at? This is array CPP. Line 35. So we're trying to allocate array, and array has the JS object macro. What does that expand to? You can hover here. cline will tell us. It expands to friend construct cell. Okay, so it's possible. I don't know exactly why this doesn't work, but instead of figuring out exactly why that doesn't work, let's try to take an escape hatch. So what if we just did friend heap or friend class heap? And then we actually wouldn't even need construct cell to be a thing here. So we could just leave things the way that they were. And then would it work? Okay, seems promising so far. Yeah, I don't know why that friendship declaration did not work out, but it should be possible to have a friend who's templated. I'm probably just doing something wrong with the invocation, but instead of struggling with that for the next 10 minutes, let's just plow ahead with this slightly broader friendship, right? Where we invite the whole heap class, because that at least worked. And then if we come up with a narrower friendship declaration, then we can just swap it out in the macro later. So this is great. But I think we have things in libjs that are not JS object, but rather they inherit directly from cell. So those are going to be in libjs. Yeah, so JS object inherits from cell, as you can see here, but we have various engine internal objects that are never accessible to scripts, but they still float around in the garbage collected heap. And I think we still want to be able to construct those as well. So primitive strings, for example, are a good example of this. So primitive string, it's exactly what it sounds like. It's just a string that you can pass around in JavaScript, but it's not an object, right? It's just a primitive, but it is GC allocated. So it inherits from cell. And as you can see here, it has a bunch of disgusting public constructors that it would be cool if we didn't have. Oh, by the way, I should mention the big reason that you don't want to have these public is that if you put these on the stack, then the garbage collector is not aware of them. So right now, it's perfectly possible to instantiate a garbage collected object that is intended to be garbage collected. You can instantiate it on the stack very easily, accidentally, and it has happened before. Because of these things, and by making them protected or private, we just take away the ability to have such accidents. So anyways, what I wanted to get to was that we don't have a macro equivalent to JS object for cells, but we can totally just add one. So typically what we put in the macro here is the class and the base class. And then we use that to create a type def or a using. And we also create a class name virtual that every JS object has. But that could also be a thing at the JS cell level, I guess. Because looky here, JS cell also has class name. So why not lift this thing up, actually? And I don't know why this is object and not cell. So let's just take this. I'm not going to do a full search and replace and make everything into cell, but we can do something like JS cell. That seems okay. And then here for now, we will just turn this into a simple JSL class and base class. Okay. All right, and then once we have that, we can get everybody to do this, right? Previous definition is here. Wait, what? Oh, see, we have handwritten class name overrides, so we can get rid of those actually, and give everybody a cell. So I think we'll start by just giving all the things that inherit from cell. We will give them JSL macros. Actually, maybe not this one because, or, well, you know what? I guess we can do this one. JSL, pre-list entry cell. It should be okay. Still allows us to get rid of something, so that's fine. Accessor. Yeah, and then it's upset because we have a class name. So this is nice, getting rid of some things, and it's leading up to something even nicer. Okay, I should edit down here. Dum dum. Permanently screwed by eval. It's one of, it's a very, very accurate description of what happens to a JavaScript environment when you use eval, by the way. It does become permanently screwed for optimization purposes. Where is class name? There you are. Okay. All right, we are making progress. Promise reaction. And class name go away. Remaining elements. I don't even know what that is. But I'm sure it's something useful. Wonder why that's on the heap. I'm just not going to question it. It seems strange to have a garbage collected thing that just carries around an integer. Okay, well, ignoring that. Promise value list. Oops, I messed that up. Promise value list. Class name no more. Already resolved. Here's another kind of mysterious thing. I wonder if this needs to be GC allocated. There might be some totally valid reason for it. I just don't know how these things are made. The realm. Okay, I need to stop instinctively pressing escape, which closes the find window. Okay, we're almost at the bottom. And then chape. Shape cell. Oops. Class name. And finally, symbol. Okay. You out. All right. How did that go? So far, so good. I think this is going to be nifty. So here is where we just make the JSL macro, and we introduce that and add it to everything yeah, that is directly subclass of cell. We don't mess with the array constructor visibility just yet. But wait, oh, JS environment. What's up with that? That needs some love actually. What's going on there? Okay, I gotta go look at that one. Environment.h. Okay, so we have JS environment, which is like JS cell, I guess, but for environments, which is fine, but we got to make sure that I guess we can do this. JS cell class, base class. Yeah. Maybe we end up just removing JS environment and JS object macros later in favor of only having JS cell, but right now let's just leave that. Okay. Yes. Leave that one for now. We will converge JS object to JS cell in just a moment. I should probably have done the same for environment actually. All right, so let me actually tweak that so that we don't change this one just yet. We just add that thing. All right. Lib.js, add JS cell macro, JS cell macro to use it in and use it in all JS cell subclasses. This is similar to what we already had with JS object and also JS environment, but sits at the top of the cell inheritance hierarchy. Okay, let's see. The new thing, or maybe I shouldn't have added the new thing just yet. Yeah, let's hold back on that thing so that that's actually part of the next patch. So we're removing the heap thing, yeah. And then we will do the environment in JS object, just forward to JS cell. Make JS object and JS environment forward to JS cell. Okay, and now here comes the heap friendship. Okay. Lib.js. Make everyone who uses JS cell a friend of heap, or make heap a friend of everyone who uses JS cell. Yeah, there we go. This will allow heap to invoke private, protected, or let's say non-public constructors when allocating new GC, new objects, new cells. Okay. So this is going to be awesome. So let's try it out. Can we still build, let's say? Okay, we're still good. So now let's do a bunch of things. So like object.h, for example. So we take the constructors here, and you come with me down to protected. All right, so we'll just add them under there. Okay. Does it still build? That would be cool. Okay, wait, hold on. Heap.h. Let's see. Wait, why doesn't it work? ECMAScript function object 211. What's happening there? Okay, so ordinary create from constructor. Oh, this is interesting. This is a wait, no, this is a free function, but it does not directly. I thought it was going to do placement new, but it doesn't. It just calls heap allocate. So we're here and we're doing a heap allocate. So what's the issue? Make constructor object public. But heap is my friend. Oh, maybe JS object doesn't have the macro. Ah, okay, yeah, of course. No problemo. And oh, now we have to remove class name. So this should have been in the patch where we added it to all the cell derived classes. So let's do a fix up. So let's see, not you, but you, not you. Object or cell fix up. But it looks like we're gonna build just fine with these. Yeah, that's going all the way through. All right, so let's do that. Okay, so what do we do with the primitive of string? These be gone. And as you can see here, the copy constructor is already deleted manually. Oh, I would have expected that to already be handled here. Yeah, so I think you already can't. I don't think you need to do these. Did I add those? I did not. Yeah, I don't think we need to say that because the base class is already non-copyable. But regardless, let's make those private and then see how that goes. So will it blend? This is very, very satisfying. Like I've been annoyed by this forever. When I was working on libweb stuff, like making more libweb things be GC allocated, it just hurts in the heart every time that I go and I take some perfectly private constructor and just move it up to the public section just so I can GC allocate it. And I was doing that for the last couple of days with various things, and now we're not going to have to do that. So this is going to be so much better. So that just worked. Cool. Let's just do more stuff. I guess we're going to have to do all things. So array prototype, I'm just going to do like a handful, and then we'll see that this just works. Oh my goodness, I did not mean to build everything there. Just JS is fine. So let's do some interesting ones like accessor. Okay, you go here. Still fine, no trouble. So cool. Yeah, I mean, I think once the pieces are in the right place, everything will just work here. it's just real nice is all. What else do we have? The intrinsics object. Ha. Down to the private section with you. Ha. I gotta say, I've been so annoyed by this so long that this feels so good. Like I don't know if I can convey how satisfying it is to move these. Let's see. Oh, does global object have a constructor still? Yes, it does, right there. But now it has a private one. In fact, I don't need to keep compiling between every step. Let's just let's see. How can I see? I don't usually use this view right here, but let's try it out. Libjus. Runtime. Okay, what's an interesting object? Let's do error, for example. So error has this constructor right here. You just go there. Or, well, it probably needs to be protected because there are subclasses afoot. So let's do it that way. Yeah. And function object, another popular fella. We can definitely see that it already has protected only, I guess, because nobody instantiates that directly. But we have ECMAScript function object, which is the typical object that you get when you have a function object that contains JavaScript source that somebody wrote. We also have native function objects, which are our own native C++ implementations of things. But this one is functions backed by source code. So is this a final class? It is a final class. Makes you wonder why it has protected things. But now it has a private constructor. Environment. Ooh, let's do that one. Or at least some subclass of environment, like declarative environment. I'm just going to do some random ones just for fun. Declared. Oh, I think that can have a subclass. Yeah, so this one needs to be protected. Maybe not all of them, but let's put them there for now. And I'm hoping that things will just build and we can do this to everything now. So essentially, I'm just looking for something to shake out any more bugs in my thinking. Oh, did I mess something up here? Let's see. Test262 global object. Oh, global object. I made the constructor private. Shouldn't have done that because it has subclasses. Okay, that was my bad. Which one should we do? The math object. Well, you don't need to have a public constructor. Maybe promises. Can promises have a subclass? Public promise. Oh, yes, there are subclasses of promise. Today we learned. So you come with me. Okay. Yeah, it seems all good. Shape. Shape is an important class and not part of the spec, but part of our object property storage implementation based on the shape concept from V8 and the structure concept from JavaScript core. And now it also has private constructors, and I hope that will also just work. I don't think we do placement new of any of these things outside of heap allocate functions. I guess the one thing that could come up is that if we accidentally break something that was relying on a bogus stack allocation of one of these things, which would be fascinating to find and absolutely a super catch if we did, but I don't think we're gonna find one. Typed array. All right, so here there's a template class in the mix. So it's a little bit of an interesting edge case. So let's see if that works out. If we make the constructor, where are you? Typed array. It's already protected. Okay. So people inherit from typed array then. So public typed array, sure. Okay, so these guys. I guess this is all the, yeah, uint8 array, uint8 clamped array, and so on. This is really cool in C-line that you hover over a macro invocation and you just, in the tooltip, you see exactly what the macro expands to. And by the way, since I'm saying things about C-line, this thing that they added is so sweet. I opened a bug about this like a year ago or something, and they finally closed it. And you can now see the offset of members and the size of that member. This is super kick-ass when you're trying to reduce the size of something. So you can go and like look at some object that is large. And actually, if you hover over the class name, it also tells you the size of one instance of the class. Right here, 288 bytes. And then you can look at individual members and learn that this vector of class field definition is 24 bytes, and it's 200 bytes into the object. Really, really nice feature. So props to C-line for adding that. Just wanted to call that out in case people hadn't noticed, because I started using it immediately when I learned about it. So what did I want to do? I wanted to make those constructors private, right? So I disoriented myself here. Declare typed array. Where is, I guess this is the constructor right here. So this can be protected, let's say. The class is not final. Maybe it should be final. I don't know if these things can have subclasses, but I'm just going to slap it under protected for now. Same thing with the prototypes. They also don't need to be public, and they are final, so we can put that under private immediately. And constructors as well here. Okay. Sure. Sure. Okay, let's just do a random handful of other ones. Weak set. All right, you into the private section with you. All right, and let's do regex object. It's a bit of a big part of the engine. So regex objects now have private constructors. Wait, why is that not final? Does somebody inherit that? Does the prototype inherit that? No. Maybe this could be final. I don't know. I'm not going to tweak the final state of these things right now. I'm just going to... or you know what? At least I can make them private. And then we'll discover soon if that's an issue. But maybe it's not. Native function. Let's do native function. Okay, you there. I mean, these are all just working. Okay. I think we're home free here, or just the home stretch remaining. So I'm gonna go through the remaining ones here and do them, but I'm not going to record it because it's just very, very repetitive. So this is going to be the end of the video. So if you made it this far, then I thank you for watching and for hanging out. I hope that you saw something interesting here today. I certainly am very satisfied with the progress on this thing. And this also reaches into libweb, by the way. There's going to be a bunch of places to take advantage of this. By the way, if anybody knows of a way to narrow down that friend declaration that I added to Jsl, so we don't have to make all of heap a friend, but only the function that needs to placement new, that would be cool. But in the meantime, this seems perfectly livable as well. So yeah, thanks for hanging out, and I will see you all next time. Bye.